previous videos, I talked about how to do feature detection within a pair of images. After finding feature points, the next step could be to stitch images by using those feature points. So in this video, I will talk about how to combine images after detecting features. So from previous videos, we use Harris and Fast to detect features from image sets. I will run the feature detection first, so we can get our feature point to stitch images. In case you don't know, this is a code from previous video for feature detection. So our first step will run all these sections, and this is our image set. The result image after feature matching looks like this. After feature matching, our next step will be create panorama. To create panorama, which is the result image after you stitch two images, we will start by registering successful image pairs using a for procedure. So suppose we have an image in image set and we want to create a panorama based on n images. The first step will be take and matching features between all images, like what we just did. And next step will be estimate geometric transformation, which we call it Tn. So in case it's not clear, we will call it Tn here. And n means number of images. Then we want to map In and In-1. So n still means number of image sets. Then we want to compute the transformation that maps In into panorama images as Tn multiply Tn-1 multiply Tn-2 and multiply till T1. So I will type the equation here. So these three equations are the equation we are going to use to create a panorama. In our case, we only take two images, but this idea can be used to stitch multiple images as a panorama. After finding feature points and extracting features for different pair of images, the next step will be estimate transformation between two images. So let's get the T transformation of one of our images. Let's call it T forms, and the number of images is 2. So we build a T forms equal to projective 2D I3. In case you don't understand what this code Tform2 equal to projective 2D I3 means, so I3 builds an identical matrix with a size 3×3, and projective 2D means this sets a property T with valid projective transformation defined by non-singular matrix A. A means the matrix inside here. In our case, it's I3, and now we're going to initialize the variable to hold image size. So our image size is based on how many images we have in our image set. So image size equal to 0s and image size and 2. So let's run this section. There's a typo here. Projective, and run it again. You can see here we already got our image size and T forms. So now I will put the equation we are going to use here so you could understand it easier. So we want to get Tn minus multiply Tn-1 multiply until T1. So in our case, because we only have two images, what we're gonna do is get T2 times T1. Because we already calculate one T forms here. Now what we're gonna do is to get T2 and T1, so we could calculate the result. So now we want to calculate T2 times T1. So just for convenience, I will copy code from what I have already coded, and I will explain code to you. So in this section, we say Tn, which n equals 2, will be generated by this estimate geometric transformation from 2D. And please remember, don't make our order different. We will match the points from image 2 and match point from image 1. We put it in order like this. Then we calculate t forms n, and then we calculate t forms n times t forms n minus 1. In our case, is t2 times t1. So now run the section. If you do it right, you will notice that the value of t forms will be different than what you got before. And one thing I want to mention is that we initialize the matrix for image size here, but now we want to get the actual image size, so we won't get errors when we are going to generate panorama. And now I'll use second image as we're gonna get here. I'll just copy paste from what I coded before. And this is image size for our second image. So we already marked here 2. And if you have n images, you will just change it as n, and you can put it in a for loop to speed up the calculation. And along the section, you can see in image size here, it was 4 zeros, but now it becomes a pair of 0 and a pair of 750 multiplied 750. Our next step will be build an empty canvas for panorama. So to build an empty canvas, we want to get the size of canvas, and just for convenience, again, I will just copy from code I pre-coded. Don't worry, I will give you the source code so you can check it anytime. And this is code we built to get the image size. So we want to get x limit and y limit of our result image. And just to make sure, it's a good way to get the average limit for both x and y. But in our case, you can see our image just only moved horizontally. So in our case, we only calculate x limit, and we run this section. You will see we got our average x limit. Also got our x limit and y limit. And after build the empty canvas, now we want to find the minimum and maximum output limit, say x minimum, x max, and y minimum and y max. So it's pretty easy because the x minimum is just the minimum of this x limit, and same as x max and x and y minimum and y max. So we run the section. Now we can go to our final step, which is to build our panorama. Now we have our size of empty canvas, so we want to build actual empty canvas. In here, let's run the section, and in the workspace, you'll see we calculate x limit and y limits, so we could get width and height. And this is the size of our canvas. By checking here, you can see it's 800 times 1248 times 3 double matrix, which means the x and y is 800 and 1248, and multiply 3 is because it's a RGB picture. We already have our x and y, width and height, and we already built an empty canvas. What we're gonna do is stitch our image on this empty canvas. If you have n images, I would recommend for loop to do what I'm going to do next, but because we only have 2 images, so I'm not going to write a for loop here. I will just show you the code, and I will do it just twice. So in here, we say I equal to im1, which is our image matrix, and we generate the transformation I into panorama, and we generate a binary mask. Then we build the best panorama in this sentence. This is for our image Y. Next, we're going to do for our image 2. So if you are using for loop, you just need to put this block into a for loop and change all this one into the name of your images and go through all images you have. But in our case, we only have 2 images. I don't think for loop will be very helpful, so I will just change whatever I need to change into 2, and we run these 2 sections. So you can see here we already got our panorama. Now we want to see our result, and we're going to run this section. You can see now MATLAB already stitches 2 images into whole keyboard, and we don't have much things going into error or wrong positions. In this video, we talked about how to stitch images based on feature points. Making panorama is still a big topic under computer vision, and this method is a basic operation to stitch images. To optimize the algorithm, you could just take random samples from feature points. Hope this video is helpful.